Okay, and we are live.
Hey everyone.
So, hey everyone, yeah. Let's switch to the README here. Yeah, so today we are going to be revamping the Xircuits code generator, which is currently a somewhat unholy mess, to call it.
It's an MVP.
Be polite. Yeah, because what it mostly does, it's just string concatenation. And with that string concatenation, well, you can spend a lot of time trying to figure out what exactly it does. And if you want to do anything about it, it kind of makes everything a lot harder. So first of all, let's ignore the debugger mode. And then it's probably going to be okay. So the first thing that that we want to start with is actually to discuss how we want to approach this.
Right.
Because there are two things. We can either send this component list and model and everything via a post request to somewhere, or we can try to parse this Xircuits file, which is a JSON file, and it connects a lot of information. Some of it is relevant, some of it is irrelevant. But it has all this information like where this came from, or what its name is, what its ports are.
Interesting. That can be pretty useful to know what file it is. So, like one thing that's a problem right now that we just avoid is name clashing, right? So we kind of import the components, and those components have global names. So if you made a print component in one component library and a print component in another component library, you wouldn't know which one is which, and you'd have to the code generator would have to rename it to kind of support that correctly, but right now it doesn't. And knowing what file it came from would be useful in distinguishing whether, right now we have ResNet 50. There might be another ResNet 50, like a PyTorch ResNet 50, for example. And when we import it, we can import it with a different name, a unique name. So yeah, there's some good, interesting kind of use cases, I guess, to having parsing the Xircuits file directly instead of kind of getting the model from the circuit from the plugin versus getting the component list directly like we have right now.
Well, technically, this is there in the component list. Like everything that's in here is also there.
Okay.
It essentially depends on what is easier to traverse, I think. So we know the links, like where things go. We have the names of things, and as I remember in this thing here, it is using like the node types. As you can see, it goes from it gets the node ID and has all nodes, and then it uses the extras and type to get there. And it's like, okay, we have the nodes here. So an interesting thing, but I'll get into this in a second. So first we have like all of this, and then we have like our node, and it has extra type, and this one is a debug type thing apparently, or well, it's a custom node. If we look into one of the earlier nodes, we can see that is a start node.
Yeah.
And the interesting thing that I want to get into is that we have diagram nodes and diagram links. So they are independent from each other, the nodes and the links.
Yeah.
So we can use the information, I guess, somehow. And well, ideally, we can ignore the links if all the information for the connections is there. But I think we will have to actually figure out what's going on. Because
I do think we need to build the graph.
Yeah, we will have to build the graph. Oh, interesting. We have actually 10 people watching us today.
Oh, cool.
Quite a lot of people here.
Yeah, that's a lot of people. So I guess promoting it on my Twitter feed is useful, or the people coming from the Discord maybe.
Yeah. So once again, welcome everyone. And if you have questions, feel free to pester us with them.
Yeah, if they're interesting enough, we will answer them. Yeah. So one thing I thought of right now is we might not necessarily need to consider the entire graph, because it's a kind of simple one, right? Like things are connected from one to the other, and it's like validated from the circuit side. So we might be able to just ignore the links, but we'll have to see, because I haven't looked into it.
I think if you look at it from this, like what information do we have here? We have this parent node for a port, which just points back to the actual node. We have those links, which probably points to a link in here. And we have ports out order, and I have no idea what that is. So I guess we can figure that out.
Well, this one only has one port, so I think the ports, they're defined in a list, but they're not necessarily in order, I guess. So to be able to line them up correctly, or set them correctly, you need this order list.
Yeah, I guess then
we
don't care about the order.
We shouldn't have to care about the order, thanks to the triangles. We really don't care.
Okay, so let's see. There is this link, and that comes from the first layer, from the diagram links, and it gives us that. There are a few points. I think the really interesting thing is probably the target value here. So if we go there, okay, that's a source, and then we are still on here, and now where are we? And now we are again in the node realm of things. So it gives us the link gives us the direct target of the node. I think we can do something with that. Let me bring up a Python console and
actually the general algorithm for the code generation is that there's kind of three phases. One, we just need to collect all the components, and then we instantiate them, right? So we'll make there's component A, and we knew that component B, we knew that. That can be in any order, shouldn't matter. And then we just need those. And then in phase 2, we hook up the links, right? Like the next things, if I'm not mistaken. Let me just double check a Python file right here. Oh yeah, so in phase 2, we hook up the ports or the values, right? So if something has a string value, we set that directly to a string. If component A's output is hooked up to component B's input, then we set those ports to the same thing, right? So we can go first by just looking at the components that there are. Then we go, I guess in order of the ports, right? We got to set one's input port to the other's output ports. We set those to be the same. And then finally, we go through the triangles and we set, the first things next to the second thing, and then the second things next to the third thing, and so on and so forth.
Mm-hmm.
Yeah.
Makes sense. So while you were talking, also kind of opened it up so we can traverse it or look at it from the way that we would see it in Python. And yeah, I think, especially because that ends up being a dict, that traversing the graph isn't going to be too hard.
Yeah, I think we can just visit each one and then do some stuff. Yeah, actually, I think the original thing was we visit the first one, then we put the node into a list, and then the ports into a list, and then the triangles into a list, and we go all the way until we reach the end. And then the code generator takes all the nodes and writes the code for that. Then it takes all the ports, writes the code for that, and so on and so forth.
Yeah. I think kind of just the first step from my point of view is to get it into a graph structure, and then we can do something with that graph structure.
Yeah.
And we have an off-topic question. So let's see. Let's bring up the question for everyone. Okay, I have a hard min-LP problem. But as we all know, the watershed in optimization is not linear versus non-linear, but non-convex versus convex. In my case, the non-linearity has a convex epigraph, which is a con. So my plan is to do spatial branch and conic and continuous relaxation in bound to construct an inner hull and branch on integer variables in one combined search tree. That question...
It's yeah. I mean, it doesn't sound unsensible to our untrained ears, I guess.
I mean, I have a vague idea of what you are trying to do, but I think that is actually getting way off topic because we are kind of getting into the math side of things there. And well, it kind of so if you think about the way how deep learning usually works, you basically start randomly and then improve your guess. From my understanding of what you are trying to do is because you have an idea of what your optimization landscape looks like, you're trying to get a better idea there, right? I mean, yeah, we take interesting off-topic questions. That is true. So just to get back to finishing answering that question, I think it makes sense in principle, but I I think we are lacking the context to actually give you a more educated answer there. Because the main problem in optimization usually is that you have no idea what your landscape looks like. So you can't really go to a local or a global because you see you don't know if that is actually like a thing. Like if you knew what your landscape looked like, you could just use an analytical answer and get there.
Yeah, it kind of depends on how many like free parameters there are that make it. So you're like saying it's a cone, right? And that's the non-linearity that's in there. And I don't know if there's some sort of parameter that can add noise into that and make it not so simple. But like what you're saying, if there's a cone and you have like some bound that you can do to like set a bound to what you're searching for, then sounds okay in principle. But yeah, totally don't have enough information about these kind of problems to be useful, I don't think.
Yeah. I mean, if you have follow-up questions, feel free to ask. But yeah, that could be a bit way too off topic to actually deal with it in this stream.
Yeah.
Okay. Where were we? Okay, so I think we'll start out with just loading the file and building up a basic structure that allows us to access any node and any link by ID.
Yeah.
So, yes. We can.
Times like this when, in your CS class, you're all like, man, when am I going to use these graph algorithms? Or I guess for a lot of us, we're like, oh man, these graph algorithms are so cool. I'm going to be hardcore. And then in a lot of daily work, you barely use graph algorithms, but they show up all the time in coding interviews. But now we're dealing with a real graph. We got to algorithm it. I'm also going to bring up my ID on my other screen. Are you in data science mode in Writer, or not Writer, PyCharm?
No.
Oh, okay.
That's just the way that I've moved the Python console to the right.
Yeah.
And I'm going to run this file and see things are the way that they should be. Yeah, I could switch to data science mode.
With that, you can like save or if they still have it, the idea is you save the thing and then be able to see it in the console.
I think I would get the same with the Scratch file. And it looks like the notes worked. But what we actually want is part of it. Okay, now we have first one appears to be finish. Now we have start. But yeah, now we can directly access things and links. And I guess it's okay. That way, don't really like searching for it and taking the first one. But that way, at least it breaks if it can't find it directly.
Yep.
Okay, so going from here, we want to find the start node and traverse it. Not just until we find finish, but until we have traversed all connected things, I guess. So
yeah.
let's
So
do
we
that.
do know that we have. I think we need to find the start node. I don't think we necessarily need the finish node, but I think the next task would be like search all the nodes for start, and then we can traverse from there.
Yeah, I was just thinking whether I should invite you to a code with me session. Maybe it works this time around.
Yeah, we could try that.
Now let's see. Quick thing. So let's see, edit files, terminal. Okay. And now do I have anything useful there? Okay, session link is copied. I'll send that over to you. And then we can see whether it works.
I have to download JetBrains client apparently.
Oh, it doesn't work directly.
I mean, I'm in PyCharm, but I think it kind of works via the JetBrains client.
Ah, yeah,
It'll
right.
take a few minutes.
Okay, I'll continue in the meantime. So I think if I rerun that in here, coverage. Can I do that? Oh, Eduardo wants to join. Accept.
Okay, I'm in. I'm jacked into the
So
matrix.
let's see. Does that work? And okay, I'm not exactly sure what's going on because the IDE is now hanging for me. Now that is about the experience that I had with Code With Me last time. If that's how it ends up being, I guess we will have to not use it.
Seems to be taking.
Would have been quite nice.
Quite a while. So much potential.
Combining, yeah, it's probably like moving data from Germany to Japan and back, and it's probably like downloading the entirety of the project folder to you or something stupid like that.
Actually, strangely enough, it shows that it's not downloading anything, but it's like uploading at 1 kilobyte per second. But on your side, I don't really see anything.
Yeah, on my side, this is completely frozen. Okay, so what have we learned? The Code With Me feature is still broken. I guess I'm going to
either that or
my IDE
you now have
and
yeah, I think you're gonna have to kill that.
Yeah, let's do that. Come on, doesn't even want to be killed. Task manager. I mean, it's not even doing anything. It's just using like 10 gigabytes of memory.
Unfortunately, we can't blame Chromium for that, or what's it called?
Electron. Yeah, I mean,
Electron.
it's fine. I've actually told it to use about 8 gigabytes of heap memory.
Yeah, that's true. The default in PyCharm, I don't know what it is, but it's not enough for circuits. Circuits is kind of way too big. You kind of need at least 3 gigabytes, I think, to run it without it complaining.
Right, there we go. And yeah, I have it on 8 gigabytes, and while it's indexing, okay, something broke badly enough that it is re-indexing everything.
Oh god.
But well, as you can see, if I click here, it goes down to 400 megabytes of used memory. So, let's see. What I wanted it to do was to execute those things. Can I like execute? Oh yeah, that's what I'm looking for. Run file in Python console. Because now I can look at all of this and don't have to remember anything. Okay, so the first thing that we want to do is we want to find the start node. So the start node is the node.
It has a name start.
It's, I think, it's special even. It is where
type is
express.
Yeah.
Start. So it has found a start node. I guess that's the one we want.
Yep.
Let's say iterating over lists to find something is not bad in Python. Like that would look worse if it was just JavaScript or Java or many other languages.
Yeah.
Okay, now that we have our start node, we kind of want to define how our path graph of this is going to look like and what we want to use with it. I'm going to use a actions import tuple because that allows us to keep it short. As you, that is for our viewers, if you, as you can see here, I'm trying to keep it rather short because what we are essentially doing is some exploratory programming and kind of going overboard with the structuring of things while you do that is pretty pointless because most of this is going to be thrown away later on anyway, when we then have an idea how things should work.
Yeah.
Oh, and Freeman has a follow-up question. Let's take a look at it quickly. Okay, the nonlinearity is an exponential. That's a non-convex constraint. So I relax it to this. Yeah. Sounds okay, I think, for what you want to do. So try it out and tell us what you got.
Yeah.
It's like, don't get stuck in analysis paralysis. In particular, when you're doing math, you can learn a surprising amount of stuff just by doing it. Like if you have an idea, try it. If you need to prove something, try it. If the proof doesn't work, try something different.
Yeah.
It's like luck favors the prepared, or as he said that. I forgot who said that, but it's like inspiration will strike, but it has to find you working. So start node, we have that, and we have the name tuple. So what we want is something that is a lot simpler than what we have in the in here, right? We want essentially something where we have the main information, which probably will sit in the extras, the ports, and the name. Right.
If we think of the first phase, we want to traverse from start until the end, and extract the names and the Python files of that so that we can generate the phase one, which is instantiating all the components.
Yeah. So let's say we have a traverse graph method, and it creates yes. Always forget how name tuples work. It gets right. This names. So we have the name, file, and we have a port, which is as a name and target. Does that make sense, right?
Yeah.
Okay. So what we end up with is we want to return a node, and it's that's going to be interesting, because in some cases there will be no file, like for the start node.
I think we're only interested in components. Did components have a specific type?
We kind of want to also have the start node, I think. I guess we want to have the...
We already have the reference to it, so we can just check if it's a start node, and if so, then continue.
So we have the name, type, and now we want the file. which may be none. That's why we're using get here. Then we want the ports. And that will be a call to yes, something like that. Let's take reverse node. Kind of a multi thing. Let's rename that. Test node. And that will run a list. Parts. Name. Yes. That. Or input parts. So now that we have opened up a port, we have a name for that. And we have a link. So we get access to that link. We are mostly interested in the target. So,
yeah. Points don't matter.
Reverse node to target. I think if we run this on the start node, we should get something interesting. Okay. Put that here and here a target. So there are ports. Or did I? So when we look at the port, we have a port here. Oh, I need to look at the links. And we allow. Now that's an interesting problem, maybe. Because we allow things to be connected to multiple things.
Yeah. Well, the not triangles cannot be connected to multiple things, but out ports can be. So if you have like a data set and you need to link it to multiple things, like let's say the test set, you hook it into the trainer so that it can show you the validation accuracy, and because you're too lazy to make a separate validation set, you just set this test set into the like validator port. So yeah, totally legit thing to do.
Yes, we want to do something like this. What's it called? Oh, the flatten in Python, yes.
Python iter tools flatten.
No, it's a bit of a stupid thing, if I remember correctly.
Iter tools chain from iterable. Yeah.
Well, that or I mean, I could also write that in a different way. That too is a bit annoying in Python. Like instead of doing it like that, it's for some reason on the other side. So now I should be able. So we want to traverse nodes on links with the link part. It's going to be fun. Can someone tell me how I managed to crash Python? Like anyone who's watching. How did I manage to crash Python with that?
You must have found a new vulnerability or something.
Yeah. Hello, we have a buffer overflow here. Okay, let's see whether it's...
You might have inadvertently created kind of infinite recursive thing.
Yeah, I could have an infinite recursive thing.
Yeah, and then once the stack is gone, all bets are off.
Okay, so it is infinitely recursive because it goes to a node that has the backwards link probably. So it goes back and forth all the time.
So we always have to have sets when we're traversing graphs.
Yeah. So ideally, if you would... Like, I'm fine with infinite traversal, but we would want that to be a known thing. So if its target is already traversed, then it uses that instead of creating a new one.
Yeah. So before we create a node, we have to add it into the set of nodes. Or have a dictionary from node ID to the node. Since we're going to need to do it by ID.
We want to collect the ID in that case too.
Yeah.
So let's get the nodes and look at them again. We have the ID field. So and we will put that. Ignore it. Or will it complain? Yeah, okay. So in between this and that, we put traversed nodes node ID node. And wondering, so if we go with node here. Yeah. So we can do an if in reverse nodes, just return nodes. The other case, we create our node and we can we still want it to be 2 steps. Because that is, we only want to start traversing the ports once we have registered it as something that we have already traversed. Return that node. I think on traverse ports, we don't need to do anything. Tuple slice indices must not be integers or slices.
Must be integers or slices.
Yeah. Okay, so in node.
Did we create a tuple somewhere?
Yeah, I've shadowed the node name here.
N.
Yeah, N. Why not? N. Can't set attribute.
Traverse ports.
Unnamed tuples immutable.
Tuples are immutable, yeah. So I'd expect named tuples to be immutable. Let me try that out real quick.
Name.
If I have A, B.
Let me check.
She's a name.
I mean, I could turn it into a class and just move on, but I always found named tuples to be so convenient.
So 1 b equals 2 bar dot b equals 3. Yeah, you can't set attribute. They're immutable. So you're gonna have to call that when you make ports, or use a class like a filthy, non-functional person.
Okay, let's have a node. F. Oh.
We could always write it in Scala, and then we wouldn't have to deal with these kind of issues. Just saying.
Yes. But then we add yet another language that is used then. And we would need to have a Scala-based Python parser, or rather unparser.
My prototype does have one.
I know.
There was a Java, there was a Java parser, yeah. But if we were gonna do Scala, it'd be probably best to have it be like Scala.js instead.
But then you need a JavaScript-based parser. Probably
Yeah.
not much better. I mean, we could.
Then we're back to where we started.
That's too. I mean, you could use WebAssembly and Emscripten to turn the original Python code into something. But yeah. So what was I doing? Right. So
you're doing the Python dance.
Okay, so we have.
Did we have records? When was records added to Python? We're stuck with Python 3.8, right?
Not sure. The records ever added to Python? Do you maybe think of Java?
There was data class. That's what it was. Python data class. And Python data classes were
in 3.7.
Oh, then we could use them. Then you can skip out on the init.
But I've already written that.
Yes.
So I guess we'll go with that. And I think the remaining part of the code should be fine. Okay, cool. We have something. I can do that. So we have traversed 4 nodes. And if we pick any one of them. Oh, you know why data classes may be really useful? Outputting them is probably quite a lot nicer. Like,
what do their toString look like? Ooh, they also have a hash. And equals and stuff like that. They are pretty useful.
Okay. So let's run this just to see. Yeah. Because without data classes, we just get a node object at this, and then we have to have our custom thing.
So just from data classes, import data class. Then annotate it, and then instead of the init, just type each, like just remove, just add the types.
Do I have optional typing in Python? So if it is, it may not be there.
Optional. Was there a maybe or an optional? From typing import optional, when did that happen? That was 310. So there is optional, but it's a 310 thing. And before that, it was union something something comma none.
How can I have forward references?
There was a way to do that. In typing, there was a way to do forward references. see, Python typing forward reference. Yes, many people are Google searching for that.
Yeah.
Forward references. It's even in the spec. So when a type hint contains a type that has not been defined yet, the definition may be expressed as a string literal to be resolved later.
Yeah. Fun. Okay, let's see. Okay, it is complaining now that this got a none instead. Oh, let's give it. Oh,
yeah, empty
you
ports
could have
is perfectly
stuck
fine,
with.
I think.
Could have stuck with name tuple,
Uh,
and I could have just added something like pushed to that list.
Yes, but just because lists are not immutable doesn't mean we should treat them as such.
Oh, there's no really pretty printing on data classes.
It'll show you how to construct it, I think. What kind of pretty are you talking about?
I'm using just pprint, and I would have liked it to be, you know, a bit nicer. Bit. No. Do that.
Yeah, the repr is just gonna look like constructor.
Still. Oh,
unless there's a way
since
to
version 3.10, it supports the pretty printing, and I got 3.9 here. I could get a package that is called Pretty Printer. I guess that's the easiest way to go about it, because that is literally only for yeah, looking at things here and kind of showing it on stream. So from it's installed now. Is it complaining that it's not? Yeah, can click that again. What do they say? It also requires install extras, or otherwise it's not going to do the data classes. Now that looks. Oh, I should
a little prettier.
That thing. Yeah. It's prettier and I hope readable on stream.
Yep.
So.
Appreciation.
Okay, we have our things. Sometimes the file is none. Okay, the file apparently is always none, so I'm doing something wrong there. But it's also nice that it shows us, hey, it's doing recursion here. So that's cool.
It's not called file, it's called path.
File? Path? Ah, right, okay.
Yeah.
Wrong thing. And now Finish doesn't have it, but this does. Great. Cool. Let's see what we have in, like, what's a more complex example, because I think we are currently looking at the easiest example we have here. So Kara's transfer learning is over 100 kilobytes in size. Let's try that one. That looks good. We have 27 links, 21 nodes, and a very big traversal here. And we do have plenty of recursion to and from nodes.
Yeah, that's smart.
So I guess we have a reasonable thing here. Do you want to bring up the actual circuit that we're looking at?
I could. One sec. Circuits. Let me share my screen thing.
Fariza just mentioned that we also have the examples that we use here don't have a branch component, and that could be throwing a branch into things. So we probably want to have an example with that too.
It should be in branches.
But we don't have an example that's using it, and I don't have actually a running circuit.
Oh, okay. Did I not have an example in the... where did we have that example? I think I called it Untitled 2. No. Well, yes, but there was a better one. Untitled. Ah, yes, this one. So you can give this one a try. Let me see if I can share that with you real quick.
Okay, can I just drop that there? Oh, no, that will give me a URL. And no, we're not going to add that to the examples. It is just complex. So, okay, we do get a pass on that.
Yeah, and it's not necessarily different, right? Like, it's just that it, if you were to go from start and just follow like the next link only, then you wouldn't get the other branches. But since we're going from everything, right, like just all the nodes, and there's nothing particularly special about branch component, just happens to have more than one triangle.
Yeah, and as you can see, it actually worked fine. So we have the branch component, we have the in 0, which is the triangle part, we have out 0, which is the output triangle part, we have the outflow when true, which is the when true triangle part,
branch. Yeah,
and the when false branch, and it goes to the next thing. Okay, nice. So that wasn't that hard. I'm kind of wondering whether we want to work just based off this, or whether we want to, have a parsed full components view available to us too, so that we maybe can get out of string manipulation. But probably we won't get out of string manipulation. We probably won't get out of string manipulation anyway, because in order to then map whatever we could get from parsing the components, we would still need to look at this, and then we can just apply the rule there.
Yeah, I'm not sure if we necessarily need the name.
It's there are things encoded in the name. Ideally, we could probably get change that in a later step. But for now, I think the target is to produce more or less the exactly same file as this unholy thing does.
Yeah, and we can start from that and then see, really, is there any benefit to having, like, as in when we look at it, the final product, is it maintainable or is it still a mess? And if it's still a mess, then we can parse the components and see if that makes things better. But in the end, we'd just be like search for component by name type of thing. Actually, because I do think there is probably a use case for not needing the components to be able to generate the code, but you can't run the code without the components anyway.
That is true. But what we can probably do, so we can put a lot more into this extra field.
Yeah.
Like we can populate it with whatever we want. So in principle, we can put any additional information that we want in here. Okay.
Yeah.
So
let's generate some code.
Let's generate some code. Right. Let's move that over so we have pretty printing available to us. Nice.
Yeah, Freeman's asking, is it unholy or cursed? I would say it's unholy. It's not necessarily cursed. It's not like you get a lot of bugs from it. It works fine, but it's like not easy. Like you can think of interesting things we could do, right, in the future of the parse, right, or the generation. So right now we're just running the file locally, or we're submitting it to Spark, or we're running a Streamlit application. So those are very simple use cases. But what if we wanted to change it? So let's say you have something that's just training a model, but now instead of training it locally, you want to deploy it on a Kubernetes cluster, and we got to do a lot of changes to the code, but we want to keep the same circuits file. And if we're working with this unholy mess of string, right, which works, right, but it's MVP, right? We have more plans, and for that we want something that's a little bit more structured to make it easier to do more interesting things with these circuit files. But yeah, that's a good question. Unholy or cursed?
And yeah, as Frieza says, it allows us to parse it outside of a running circuits application. So we can just have the compiler and the file, and Jupyter doesn't get involved into it. And yeah, kind of looking at things.
but that doesn't matter.
So now that we have that parsed, we are beyond what I have prepared mentally for.
I'll start with phase one. Get all the components. Make a list of the components. And then, like, ideally what we want is the imports that we need to do, and then the component names that we need to instantiate. And they can be in any order, but we need to map them to a variable and then generate the code that instantiates that variable. So we could either, since we have the class, I would say we can take the class and then make a generate import method that generates the AST for the import. And then we can see how that is generated, and if it looks good, then yeah, we can have we can have different phases. So phase 0, it would be to generate the imports. We get the imports for everything, unique those, because we only need to import things once, and then we output it to the stream. Then we generate the main method, and then we go through all the nodes and instantiate them. So we'd have another method called like generate component instantiation or something like that, that would create an AST node for defining a variable. And we need to figure out how we're going to name that variable, but we need to have a mapping of, like C1 is this node, and the code for that is something.
Right. So phase 1 is essentially finding unique components
and importing.
And for everyone, we want the AST statement. So before we go there, let's play around with the AST a bit. So we can pass something like import food from bar, import m from x, and is it yeah, I've used too much JavaScript lately. Bar import foo, x import okay. It's the amp and
So let's zoom in.
Vent. Okay. Oh. That's better. So for our, let's see. That looks reasonable. I mean, what we could always also do, that's I think that I was thinking about, just coming up with that is a bit annoying, like on its own.
Yeah.
I mean, for import from, it's kind of fine, but in some cases it can become harder to work with. So one thing that we might do is to use strings internally, like if we have something that will get the things that go in there, will produce the string, parse the string, and then give us the AST node from it. That's kind of a hybrid approach to, well, that kind of thing.
Yeah. But I mean,
you don't have to.
I think this module declaration is literally the like the code that you would need in Python. So can you try running that? So like if you import, like from AST import star, and then just run this module thing, does it work, or is there something we're missing?
You mean, so let's call that first. All right. This is annoying.
More space.
Do that? Yeah. So we have our parsed thing. What did you want to do?
So when you printed the parsed thing, right? It's like module body import from. Like, could you copy that and paste it, and that works fine? Because if it does, then you can like copy these and make a little function that just returns this, and then we take the parts that we care about and make those
obviously
function parameters.
We could do that too. Yeah. It's just harder to change.
Yeah, so the main thing is like the alias stuff that we want to. So one of the features, right, having two different components with the same name, they have different files, so we can create a function that aliases them to something special. And then we have some interesting feature that we didn't have before.
So what we do have here is this. So we can alias them. Mm-hmm. So regular thing is just alias name, and you can then have an as name thing that would give it a different name to use if aliasing is necessary.
Oh, and then how do you go from this module, AST, to Python code?
Okay, let's add this more complex thing there. Okay, so we have this parsed thing and this AST unparsed. And it's
okay.
So it's literally like that then.
So you just take all the like we would get a collection of AST things, and then we just go through unparse them into a file.
Exactly. And we probably want to collect them in different places. So what I'm thinking about is if we go through our nodes and ports, we could essentially emit a few things like an import and other things.
We would like traverse it, and then as we get to a node, we generate, like, I would say we have a node, right? And then we say, generate import. We put that import into a dict, right? Because we want unique imports only. Then we can generate the instantiation, right? The phase one thing with another method, and then put that into a dictionary. And then when it comes time to generate the file, we then just take the imports, unparse them, print them to the standard out. Then we take the instantiations, unparse them, and that would work for now as a first step, I think.
Yeah, I'm thinking, so the thing that we are kind of discussing is kind of a visitor pattern thing. Does Python have something convenient for us? No. Have to do it ourselves.
I mean, just generators, right? You have a generator expression for calling a function on something, and it could be a method or a function. Doesn't really matter much. But since we have the classes anyway, I thought just having a method to generate the import for a node would make sense.
Oh, you mean put it up here?
Yeah. You go to node and we make a def generate import.
And we could actually make that like the thing that we return, put it into a set that makes it unique by default.
Yeah.
Yeah. So generate
component instantiation. Is there a more intuitive name for that?
Object creation. Generate new. And generate. It's generate assignments thing is going to be probably
there's two assignments. Yeah, the generate assignments will require the result of generate instantiation, I think. But we can figure that out later. Mainly because when you look at the generated code, you'll notice the not that one, like the code we currently generate from compiling the Xircuits file. We assign each thing to a variable, and we're going to have to use those when we do the assignments.
So in the AST, everything is still string based.
Yeah.
Interesting thing here is the context equals load, context equals store. I mean, what we had was a.b equals c. So it has like a name that is being loaded, and then something where we're storing, another thing that we're loading.
So, yeah, that's interesting.
Okay, so to come back to the assignments then.
Actually, let me send you a compiled file so that you have something to reference.
Yeah, right. Do that.
So I'm going to send you untitled.py. One of the many that I have. Oh, it sends you stupid Slack. It sends it as a.
Yeah, but I can still download it.
Yeah.
Fortunately, let's drop it here. Really, that's like looking for usages. Right. So for everyone who isn't familiar with our currently generated code, So we have some imports, and there's the main. And well, we start the context with something. Then
This is
we
the instantiation I'm
instantiate
talking
everything. Come again?
Yeah, these are the instantiation things that I was talking about. And then
Yeah.
Next is the port assignments. And then the triangle assignments.
And then the execution.
Yeah,
Which
and that's like
clearly
hard coding,
says
essentially.
that started, and that's where the next stuff is. Okay. So I guess you'll start with that.
Yeah.
And we will also want to, like, it feels like there is something that needs encapsulation here. And because the traversed nodes that we have in here, they're only really relevant while this is going on. So I kind of think that we want to have a circuits file parser.
Yeah.
And there in it. That translates some sort of and that. And we probably, like, all of this also doesn't make. Yeah, exactly. Like, I think we want to point it at a file or something.
Yeah.
We get that. Yeah. And we return node. Let me start. And that means our graph. So we have a circuits file parser. Let's see whether that still works.
Need more self.
Oh, yeah, I need more self. Because those things depend on the existence of nodes and links. we have that. Yeah, that works fine. Okay. Nice thing is that I can now hide it.
Collapse it. Yeah.
Yeah. Okay. We have the Xircuits file parser, and now we want to, I think, have a code generator.
Yeah, that takes the graph and generates the code.
Should it kind of feels like it should take the entire graph.
Yeah, it should take a graph.
On its instantiation.
And then the generate should take a file like object to print to or something like that.
So that we get to something like this, I guess. And our thing. Okay, we don't care about those warnings, they're about the pretty printer, and it prints our to-do message. Great. So we want to create the import statements.
Yeah, so there's the fixed import statements that we need to generate regardless for argparse. What else?
So we have imports that
we don't use datetime anymore.
Come again?
We just need argparse.
Yeah, I think those are only here for the debug stuff.
Yeah. Well, datetime is actually because we had a required argument earlier called experiment name, and if it wasn't passed, we would set experiment name to be like the name of the file plus the date and time. So that's why we use that.
I see.
But for Streamlit, that was causing problems, so I got rid of that.
Okay. So we only really need that part.
Yeah.
And I think let's get like do we want to prefix it with an underscore to mark it as private? I think we want. So, and that thing let's do import AST. it actually makes sense to do something like this. Then turn ist parse imports body. So that we do a ist unparse here with, oh, this has currently restarted at some point. And let's have something like that. We don't really need to print it. We have that available here. So we have st module that then has a list of whatever. So let's have st module, and as its body, we are going to give it just parts. So that complains. Expected type AST got module instead. Unexpected indent. So that's from here.
Yeah, so you're gonna want to have that in like a single line. There's only one, so no reason.
At the
to make
moment,
it
there's only one.
thing.
Like, but I mean, if it's like if we have something like that, I would like it to be like very easy to add new things here. Isn't there a way to indent this? Or
there's a way to do that in Scala.
Yeah, that's why I'm asking. I mean, we can do that.
Is there a way to do it?
By interesting. If we use that.
Well, you did take the body from it, right? Was the body the module or something else?
No, I want to be able to do the module itself, like on its own. I guess we need to give it a type ignores.
I think what we need to do is map the imports to unparse.
Kinda, but what I'm trying to do here is to see what we can, well, what we can do. Okay, let's take another look at this. Our type ignores needs to be a list, and that list is empty. And the chain is not a list. That makes sense. Yay! We managed to get a round trip.
Yeah. It's quite the round trip when you think about it.
Yeah. I mean, for just outputting a fixed thing, that certainly is that. However, now we want to generate And that needs something else. So we want to have unique points. And that is going to be a set. And so we want to iterate through all nodes that we have in the graph. And we want to
get the names.
and we want to ignore their what's the thing? We want to ignore their. We want to ignore the nodes that we've already visited. So that's one thing that is coming up, I guess, again. And that is nodes that we have already visited. It is in the Xircuits file parser, and it is in here now too.
So don't we want to get it? Right, because we're returning the graph and then we're like throwing away the parser. But, you know, in the more imperative way, we don't necessarily need to throw away the parser. We can parse the file and then, you know, use the parser state for the graphs and nodes and stuff like that.
So the thing about traversed nodes is that it is a dict, right? And we will want to traverse things multiple times. So we kind of want to keep that dictionary. So we want to like reset it sometimes.
Well, then we can make a reset method.
And we could just have that as some state for the code generator. And it feels like there should be something better for it. Like, well, I'm imagining something like a traverser that can be given the graph and a method. And that will call that method on each node in the graph.
Yeah, but only once. In the graph.
Oh.
The graph has.
Hey,
I see.
Yeah, Freeman is asking whether the stream has stopped.
Oh.
I mean, it works for us, I think.
Yeah, I can still see it.
It's just not writing anything. Like, there's no new code on the screen at the moment.
My iPad is working.
It appears to be working for others. So okay.
Yeah.
Let's continue there. So yeah, it is kind of like a map that I'm thinking of.
Well, we have graphs, so we're gonna need sets. I mean, you could just first walk the graph and then just put every node into a set.
Oh.
But we need to have a proper hash. And our hash might not be good enough right now because we're using the default in data class. We could override it so that the hash depends only on ID.
like that.
ID dot
hash
hash, I think. Yeah. Yeah. Now you can just you just go next, put it into a set, and now you have the unique nodes. But you do want to filter out the start and the finish.
Yeah, I mean, for the components, we kind of want to do that. So let's have def node set, and that is set. Node equals. So current node is not none. We add the question that Freeman asked. Eduardo, if you want to go into that, feel free to do that while I'm doing some grunt work.
Yeah. So essentially, the question was to prevent excessive branching on integer variables, one can ignore sub-search trees worse than a feasible solution. And another way to remove branches is to see whether an integer assignment for a given relaxation is flexible by minimizing that variable and seeing, if those variables are in the interval, right? So again, not too sure about it, but like it sounds like a dynamic programming thing where you'd have a table of, usually when there's dynamic programming, you have, like a x-axis and a y-axis of things, and then you start at like the top left, you do something, and then you go right or down, doesn't matter which one, and then try it again with that, but then save that state, and then based off of whether this one is lower or this one is lower, you change which direction you go next. And if you find that you're like traversed too far and you got to go back a few, as in one of the other states is better, you have the table to that you can cross-reference to see where you should go back again. So yeah, that's kind of what I was saying. Dynamic programming, if you know what that is, it sounds like it could be useful. But if the problem is actually too complicated for dynamic programming, the table isn't the most important part about dynamic programming. It's like a graph type of thing. Like we're doing graphs now, but you can have you can build up a graph of what you've done so far, and then make it be like a search space. You have this frontier of things that you haven't done yet, but you store the cost of what it took to get there, and then you can have a min heap essentially, where you have the lowest cost is always on the top, and you take the lowest cost and you do that. So it kind of becomes like a breadth first search way of going about optimizing things. That could work. And yeah, I've never worked on the MILP solver, so yeah, I'm not too sure about that.
Yeah, the MLP server, certainly not something that I've used recently.
Yeah.
Okay, what was I doing? Right, this. So to build the node set, we have essentially a queue of nodes that need to be visited. We do that until it is empty. So this is kind of a way of not building this recursively, so I don't have to put this state somewhere. And yeah, actually, let's see. So an empty list here and just print the nodes of this. So that looks reasonable. We don't have, yeah, we're not putting that at the end. And this gives us all the nodes, and they appear to be reasonably individual. Okay. Now, what we do next? So we want to have unique components. And a component is essentially just a set of the name and I guess the file, right?
Yes. To know where we kind of have to convert the file path into an import.
So that would give us a set of tuples for the name and file, and essentially give us the unique components. Yeah, we need to create the list in between. And I think that would allow us to have list. Yeah. Or main L. Oops. I guess we're going to have something like imports and see. I guess we can go with the direct import here, as that is an import from. It's going to be wrong for to do. That feels okay-ish with that. It's for the first step. Let's see how that blows up. Oh.
Did we call it? Yeah.
We did call it, but I had still the return with the empty list there.
Cannot multiply sequence with none.
Hey, that suggests that whatever we've produced here isn't quite what it likes. Okay, let's do something. It could be because at the moment we are just passing the file and it doesn't accept that as something acceptable. So our module would be simply file.
Is not. We need to split it with the path separator, and then take those components and join them by dots.
Let's see that I have things. Right. List object has no attribute join. What is it in Python if it's not join?
String. You put join on the string.
Yeah, it's another way around. Yeah.
It's the backwards. So dot join.
Okay. Non-object. Okay, that makes sense.
Sometimes. If file exists.
Because our special things will have a none there. Okay. Now this is probably from the way that it is trying to do things. So let's try ast parse if from this import
Why did path sep? Is that a function?
It's probably not what we think it is. Probably something. Let's make it explicit.
Python import OS path sep. Path sep is colon because it's separating the.
It's separating paths. Yeah.
Yes.
That's why I'm saying it's something different. And we want to lose the .py. And we probably want to, so let me take a look at, we do all of that, but we could actually like have multiple things on the same import statement if we group by the file first. And I mean, why not? Well, first, and we have
and
a nice
is what
by method. Iter tools. So maybe that to get our and group by and So we can through that and oh, split the file.
Oh, this is smarter. Yeah.
Think. And then we have like that. Yay! That looks
Sweet.
sweet. An interesting thing here, though. So from XAI component, XAI workflow branches. Why do we have that split? I mean, I see that same split in here too, but why? It should be coming from
Is
the
the file
same
different?
file name.
Yeah. Do we have to chomp the file or something? It should be in control flow. Yeah, there's only one file in control flow.
I mean, let's look.
Do we need to sort first?
Do I have to turn it into an explicit dictionary first?
Not values, or yeah, items. Too much Java for me.
Like so. Okay, so it has a grouper object here, and
so I did that file while I was developing it. So there's a chance.
But, I mean, we do get the same keys, so it should be only. I think it is something about the way how itertools does that.
Oh yeah, itertools might be like the Unix unique function, right? So it kind of depends on things being sorted.
Why is that empty now? So turning this into oh, that thing doesn't have items anymore. Oh. Ah. That feels like things being consumed. So if we try to turn that into I mean, we can back into a list and sort it by just sort it. We don't necessarily care how it's being sorted.
Yeah.
Still comes out that way.
So weird. Why in the world is content?
Yeah, let's Okay, it does depend on the particular sort.
Okay, yeah, then group by in IDER tools works just like, it's just like the Unix tool. You need to have things sorted and then it'll group it perfectly.
I guess makes sense, but
yeah.
Okay,
unexpected.
So do
you think you'd do more work?
Yeah. We do get things that way, and I think it's like using small snippets of code that are then passed by AST makes sense for us too.
Yeah.
So Freeman, have you people played around with ChatGPT for development? Yes. And we can confidently say that it is great at bullshitting. Like if everywhere where you need nuance, it's like confidently will tell you the wrong answer.
Yeah, and I mean, not just ChatGPT, but also what was it called? The GitHub one.
The Codex.
What was the GitHub one? Codex. Yeah,
like
called, I have
Copilot. The model is called Codex.
Yeah, Copilot. Yeah. So I was a beta tester in Copilot, and I genuinely tried to use it for coding a couple of times. And man, it's been a long time since I've had so many bugs in my code, right? I'm not a fan of using it because it generates code that looks perfectly reasonable, but it really has no idea what you're trying to do. And because it looks reasonable, it's easy to like humans, when you're watching someone code, sometimes you'll see this like blatant error that they're missing because they are focused on some other part of the code at the moment. The code that Copilot produces can sometimes have that effect where it looks good enough, so you're like, okay, perfect, seems reasonable, looks good, and now you've convinced yourself that it's correct, but it's sometimes wrong in subtle ways, right? So yeah, I'd have things that would crash in not like in production, but like I would actually try the thing and then I'm like, oh, that doesn't work at all, and that's because Copilot was just making stuff up. So it's ChatGPT is very useful for looking up like programming language syntax. That I think it will confidently do correctly, but like one issue that I've kind of seen is if you use it to like say, oh, how do you do an animation or center something with Tailwind CSS, it will say something, but what it said is actually Bootstrap code, because there's more Bootstrap code than Tailwind CSS code on the internet. And so it just makes stuff up, and there's really no way for you to tell. So you could like copy and paste that in your code, and then it doesn't work, and you're like, why doesn't it work? Isn't it supposed to work? So yeah, in the end, it's good for like learning a programming language, but as is, it's not going to be very helpful for like coding. But we have ideas of how to make it more useful. You have to just wait and see for those.
Okay, so then next thing is generating the main.
Yeah.
So I've
that
looked at how things should look like.
Mhm.
So we have a function definition, it has a name, it has arguments, and so on, then it has a body. I think it's probably the easiest for us to start with some more fuzzing. Something like that. Because by going there, we get most of the things, and then we just replace its body with whatever.
Yeah. Will it indent for us properly if you have statements in the body?
It should.
That would solve so many issues.
And
Well, maybe not solve issues, but definitely makes things easier if we don't have to worry about indentation.
yeah. So we have the main itself, now we need to give it a body. And put something like this there. There you go, indentation.
Yeah. So the first thing we do is we initialize context.
Yeah. See? Works great.
That's awesome.
So initializing the context is going to be the same thing everywhere, right?
Yep. It's just going to be creating a dictionary, calling CTX, and then setting the args to the args so that if you had a component that wanted to access the args of the function, it could use it. One of the use cases of that was the save model component, which would save a Keras model. It would use the experiment name to save the model with a unique name.
So we can start it like that, again, with easily modified code. And then we can body with something else. And yeah, cool. That works. So we can just add whatever we need here.
So now we gotta generate the instantiations.
Okay, generate the instantiations and come up with the variable names.
Yeah.
That feels like something where we may want to add additional information to the graph. For example, we may want to know what variables each node has. why not? Start and finish nodes, we don't care about them. As for variable mapping.
Yeah.
So if we go with...
We don't necessarily want to change the variable names, so it's not like there's a reason why we want to change them. It's more like, So for example, one of the use cases that we're going to do soon is to make an embedded circuits diagram, right? And one of the ways, the stupid way of doing it, right, the easy one, is just like shelling out to Python and running the thing. But there's no way to get stuff out, right? What we kind of need to do is take some other graph and embed that into this one. And we need to make it so that the variables of that one don't clash with the variables of this one, right? So we have a separate scope. So with this parser, if we do encounter a subgraph that we need to do, it can append, a scope, right? So let's say we're using the same style, C1. Let's say node C3 was the subgraph, then we'd have like C underscore 3 underscore C underscore 1 type of thing, right? You can totally do that with strings, but with this kind of setup, you actually don't need to scope it that way. You could actually, give everything a unique name, like, and guarantee that they don't clash with each other. And compilers do this all the time when you're making variables and calling functions. C can inline functions, and when it inlines functions, the names of the variables have to not clash, and so it will, generate names that are unique, so that in the assembly they don't clash with each other.
So what if we think in
and Freeman's follows up with the ChatGPT thing about like using it to explain code or documentation and these kind of things. And I agree, like right now ChatGPT is great at being like, hey, fix this English for me, or say this another way, or summarize this, or translate this to Japanese. It's really good at all those things, because you've grounded at what it can say to your input. So similarly, when dealing with code, you should probably treat it the same way. And those things that you're talking about are exactly the same kind of use case. So like, explain this code, right? Or can you translate this code into Python for me, or C++? And it will typically do that much better than just generating new code. And yeah, I think everyone was kind of surprised. Even the people who found the attention architecture were surprised. That's why they made such a meme-like name for their paper about like kind of how simple it is. So back to code generation.
Back to code generation. And how it's supposed to look like. I kind of feel like it's probably the best to simply use astparse to create those tree fragments.
Yeah, it gets a little involved, and with the stores and loads and stuff like that.
Yeah, it's and have that. Yeah.
For the next one, I think let's use AI generated background music, because it'd probably be more interesting than the current background music.
Yeah, I mean, feel free to change it to something different.
It's not too bad.
It's repetitive.
Yeah, but it is getting repetitive.
Let's see what we got here now. Okay, that looks reasonable.
Yeah.
Let's compare it to what we had previously. Okay, just that we start at 0 instead of 1.
Yeah. Have a different order of things, but the order should not matter.
Yeah, the order should not matter in that case. Okay, cool. We're making pretty good progress, actually. So that is instantiate. The next step is going to be more complex.
Yeah.
Okay.
We're going to need a map of like variable names to nodes so that
we have.
we're iterating the nodes.
We could, let me give it a, instead of doing this, let's do that here. Have it like that. That gives us the node variable names.
Yep.
Okay, so for every node,
Yeah, Frieza, I understand your point, but you know, it's a program and OCD doesn't matter. I mean, so it's it literally doesn't, it shouldn't matter. And when you're looking at the generated code, the order of the things, like right now, it's from start to end. But once you've added a branch component, like what's start to end, you can't really tell. Like, do you put when true before when false, right? And that's like arbitrary anyway. So the order of these things is, you know, it makes sense until things get complicated. And because the order doesn't really matter, or that it shouldn't matter, it's actually good to make things that shouldn't matter actually happen so that some sort of like dependency doesn't creep in, right? So, you know, the code is that we generate is not really meant for human consumption, so it's fine if it's a little dirty.
Okay. One thing that I'm noticing that we probably have not even touched at all is that we do have those literal values, right? We probably have them in here. Oh, it's probably easier to talk about it here. So we have that literal value, that literal value. At the moment, we're not even parsing them. Like, we have no place for them in our node graph. So
we don't.
if you look at as
there should be literal nodes in the graph.
They probably are. Like, we have this node which has type string, and it has a port.
Yeah, so it's a literal string. If you look
Okay, so
at
we have the
name,
literal string in here.
yeah. And then the value is running. So it's the label. So
Yes,
if you look
but
for
it is on the
literal
port.
Boolean.
So we are not pulling that currently like properly in. As in, so let me print our graph here. And look for
Yeah, look for true or false, I guess.
No, it should be there as a
Oh, yeah.
actually
there should be like
isn't
literal nodes.
Yeah, exactly. It should be there as a literal string. Isn't.
Is it in the links or?
Yeah, let's take another look here. So it should be a custom node with that ID. I guess we can check for that. For whatever reason, it tries to. It does this weird stuff. Am I pointing it at the right file? Complex. So it should certainly have that.
Yeah, so
Unless
Untitled Pi
it isn't
has
connected.
Yeah, I mean, it is connected. It's just connected in a weird way. So if we go back to my screen, switch to my screen.
Yeah, I just did that.
Okay, so yeah, so essentially the is running is this literal string here, which is used to define the variable. So if we go from start, it's not connected to start. You'll never reach it because it's not a triangle component. It's a special component, like these literals.
Yeah, but
so
like because we are looking at the links only, it should have collected that.
I think so too.
I would have expected it to collect that.
Yeah, we should see like 5s and -1s. And the strings, it's true and it's false.
I mean, for those, like they have this, unfortunately, a kind of weird way of being defined. Where we need to pull that from the port label. What is the other one? Like literal true?
There's literal true, literal integer.
That's also on the label. Yeah. Always like as a string, as a label on that port. And so we're following ports in the target direction. But I guess we should also follow them in the source direction. That's the missing part here.
Yeah, but not the I guess we don't necessarily need to do it for the triangles, but for the other ports, yeah.
Do we want? I think we want also add a source on Yeah. So we do it like that. Okay, now we have literal strings, but literal strings do not have their value yet because it's attached to the part in a kind of weird way. Now, how do we handle that? I guess we can have a part value on it. So ideally,
essentially
a
all we care
literal,
about.
like
There's
yeah.
two types, and there will be three, which is we have the literals, which there's a small handful, and then there are the arguments, or the hyperparameters as they're called today. So those are special things. And later on, we might have another special thing, which is like a mathematical expression type of special. So in the generator, we should have a collection of those special non-component components.
Yeah, I guess I'll collect the value for like a literal value from a port label, and then we can do something there, maybe.
Yeah.
So let's
I think
see
for arguments, that is the argument name.
Interesting. Because there is a label on all things, like on all parts, and usually it is the
triangle.
Yeah, the triangle. Just because you know this can't show it. It looks up weird. That's like when false, literal value is message. On that part,
well,
but here's like a note with a literal string that has a part, and then we have the value. Okay. So I guess we start by setting up all the literal values.
Yes. We can do it in line. Literal values. Yeah.
Now, the annoying thing about that is probably like that we now need to do some string matching. If it starts with literal and is not a file, like it doesn't belong to a file, then we check the literal value here.
Yes. So there should be so I think it's worth like making that be like a global thing. There are a few special nodes, right? There's the start, the finish, the literal string, and those things. So defining them as things we're explicitly looking for makes sense.
Does Python have a starts with? So, and that is probably going to be fun for a node in the thing here. What do we set? Is the node
Ports, yeah, 0.
ports? So I'm looking at source or target on this port, and I guess it needs to be the second one is node 0. Has it found no literal nodes?
Have you added those? It's 2 parts.
Yeah, I mean, everything that starts with literal. I mean, let me
unprint the graph one.
Yeah. Oh, that is empty. Why would it be empty?
We're looking for ports that have the name, but you're looking at nodes that have the name literal.
No, that is on the node, as you can see, literal string.
Oh. Why is it in 2?
That is because pprint is stupid. As you can see, it's like on the ID also. It's trying to save space. It should be in the node set. Do you want one where file is none? As we have here, file is none. And the name starts with literal. Let's restart this. And
check nodes, yeah.
As a generator as a node set. So that node set has 11 nodes. And none of them
has
literal.
It only has components.
Did we do something? Keep it here.
Node Q. Port to target. We append port to target, but we never append port to source.
Yeah, right. That was created before source existed. Okay.
Now we have these triangles showing up. We don't want the triangles.
Okay, why did we get that? Probably because I didn't remove... Yeah. Like, it shouldn't find any of the... Okay, let's reduce that. Okay. And now outputting it with all the recursion is a bit silly. Because it literally puts out, like, prints out more than it can handle.
Yeah, that's the problem with having doubly linked things.
Yeah, but it does obviously find something. So let's have the first thing. Literal string. That's fine. Then it goes to its port, which goes up out to infinity because that's the entire application or the entire thing attached to it.
That might end up being a problem eventually.
Only for pretty printing. Yeah, in this case it's okay. So let's have it.
Wait, which assignment is it running? Is it running the first one or the second one? I guess
it must be in here.
Yeah.
So let's have whatever it is trying to parse. So we can print the code.
But print.
Yeah, sorry. Okay, C0 is running, which is obviously not quite right yet.
Yeah.
And C8 is that. Okay. Node name and we already know what the literal value is. I probably still want to have that for the mapping.
Actually, for now, just wrap the thing in single quotes so that we are just setting strings on everything, no matter what. I know what this is. This is the comparison operator. There's a math operator, right? Do math. So that's why we have the angle bracket there.
I see. Let's see. Okay.
Yeah, that's almost good.
Yeah. And we're passing that as literal string, and because it's all literal strings, only the literal strings should be turning it into a string. Whereas for the other ones, we want it to be not a string. So if node name is this isn't JavaScript again. Value is value is that. That should take care of this particular thing. Okay, that looks reasonable, I think. Also quite interesting that it decides on using different escape mechanisms depending on whether there is a quote in there or not.
Yeah, we got a...
Actually, I think the AST pass thing is maybe a problem here. Oops. Because if someone is using regular quotes, then it would fail.
Mm-hmm.
So we use that. So we want an AST assign with a target and a value, because this is great. So we can set its literal value to a constant, and I guess that we can replace the actual thing. So wait, very similar to this actually. We're just going to set the name, and we can go a bit beyond what we did so far and put value.value there. The actual name will be something that you'll have to look at. So I'm going to keep that as kind of broken for now. And now we can be like template body 0 value equals value. That here. And either this is going to blow up or
That's great.
Getting closer.
Ish. Yeah, getting closer.
Ish. Because for the literal string, it stays the same. If the here go to a switch there. Does Python have a switch even? It's same
That's
every
new.
time. Does it have that, or are you supposed to use something else? In 3.10 there is match.
Yeah.
For everything else,
So we got if.
Use if else. So how many literals do we have?
So we have where is my Where is my... Did I close it? I think I closed it. 1 second. Let me open it again.
I have it here. So we have the literal string, integer, float, true, false, list, tuple, and dict.
Yep. And then we also have that get hyperparameter stuff, which will change. Or you can change it now. Yeah, you can call it to argument string.
I don't really like about that is I don't really like hard coding all of this, but
yeah, I mean it should be, there should be like a dictionary right at the top, global, of the special notes, because you can't extend these in circuits. They're fixed. And the generator needs to know about them. So let's say in the future when we add the output nodes, right, for subgraphs, those would be like, set output string and set output int, and we need to be able to add them somewhere in the code, and then they're like constants. They're constants in the generator.
Yeah, so Mansoor is saying that there is a PR up for that name change. So I think I don't want to produce any.
Okay.
I want to produce a merge conflict there. And yeah, for DIMS 543, that is an English stream, and we are talking about, well, we are creating a new code generator for the Xircuits application. And the Xircuits application, if you want to learn more about that, you can go to xircuits.io and read something. And it is meant to make AI tooling simple for everyone. And it would look something. Come on, read me load. Yeah, it looks something like this. And from this kind of graphical program definition, it produces some Python code. And what we are currently doing is we are updating the code generator for that. So, okay, back to topic then. Where was I? Okay, in here. So, yeah, Eduardo, you said to have a dict for special handling here. But the special handling is different everywhere, like everywhere where it's necessary. Or ideally, it's only a single place where it's necessary.
Yeah. What I mean is there should be a, like a global at the top that has a list of all the special cases, and then, and then we have like a function that, well, maybe not a function, but there's a list of the special strings that we need. So we just go through the list.
Right. Now, what I was saying, why I don't like this approach very much, is that we would need some, I guess, parsing of the string to turn it into something acceptable.
Or we can make classes. We can make a literal string class, subclass node. That
if we are going to,
when we parse.
Like, what happens if we do it that way? That looks reasonable. The reason why like I didn't want to list all of them is that once we get to list, tuple, and dict, that would have that would become kind of like writing a Python parser to get the value that they want to have there. Yeah, and technically, if the value that they have there is broken, we probably want to break during the parsing, like during compilation of the thing, instead of at runtime. So I guess that is fine. It also shows us now a different problem. And that is...
we're not setting it right.
Yeah,
So
we're not setting it to the right thing.
Code, yeah.
Exactly.
So in the generated code, we're like going through the ports, and then if the port is connected to a literal, then we set the value directly to the literal. If it is not set to a literal, then we set the output, we set the input port to the output port to the input port of the other thing. So essentially making them the same object. So when the other component sets the value, well, then the downstream component is going to read the same value because it has the same reference to the same thing.
Yeah. So, but this is the first thing that I'm looking for.
Yeah.
And we currently don't have that. Do we have the information for it?
You should. This is now phase 2. So we need to see the names of the ports.
And I think maybe we should rename literal value to label, because I think that may be the thing that you want.
Label.
And it's...
I see. Yeah. Yeah.
So we get the...
I can't do anything about it in Project Storm, but we can call this label here.
I mean, it is called label in there too. I've called it literal value.
Oh, I see.
Because that is the way that we have been using it. Okay, let's refactor that change and run. Okay, we still get the literal values. And how do we know the variable name?
It's the name of the port.
It is, I think, 2 things. Is that and the name of the port on...
Yeah, the label of the port.
Do we have a direct node lookup thing? Because it's the name of the port on the node.
Yes. Of the current node. So we go through the nodes one by one. And in order again, does not matter.
So text node.
Yeah.
It's 0 target. And it's like we need to find
where it gets
the
hairy.
right. Yeah, it gets hairy here.
Yeah.
Because we want to find the right port.
Or actually, we're in the literal. We're not necessarily setting up the literal values, right? We're setting up the ports. So we should iterate over the ports, and we see if the port is a literal value, then we do what we do now. And if it is not a literal value, then we take the value of the of this and set it to the variable of the destination.
Yes. Kinda. Not entirely sure I follow. But I think it's getting closer.
That didn't change anything. Yeah. Yeah, that surprisingly didn't change anything. So I'm like going,
that did change everything.
Oh, okay. There we go. There we go. I see. Yeah. 0.name.value.
.up.value. B.value.
Yeah.
Step value. Start number. Value.
Okay. So those are done. And so what I was saying was that we don't have to necessarily extract the literals and then set them. We can just iterate through every node's ports, and then if the port is a literal, then we do this, and if it is not a literal, then we assign the target into the source, or we assign the source into the target. And if you look at the code, the generated code, I think it might make sense.
I think I know what you mean. So this appears to be independent of the node type. Almost.
Yeah.
Because the
so
value
is for yeah, that's only for literals.
And the actual value. So we want to set value to something. Yeah. Okay, run this. And it's not defined because this node. And apparently that doesn't quite work. Because sometimes the label is
the arrow. Yes. And so we want to not have the triangles. And that includes the branch components, right? So like the triangle is not special. Or yeah, we can actually use the triangle because we will add it right? We add a triangle on the port if it's that. It would be better if there was like, I'm not sure if we had a property on that to filter, but we can look
That's
for
why I
triangles.
wanted to kind of go first through the literal nodes, then go through the let me add. Okay, so that's why I wanted to go through the literal nodes first, then through the component nodes to set up the other things. Because that makes it easier to.
Yeah. So there's there's links to components, there's links to args, and then there's links to specials like the literals, right? So the generator, in my mind, that makes sense, is we go to a node, then we go through its input ports, and if it is, so depending on what it goes to, we then generate either we ignore it, which is the case for, like in this phase, we're ignoring the links to components. So if we look at the target, if the target is a component, we ignore it. There's nothing we're doing. But if it's a literal, or if it's start or end, we ignore it. We don't care about that. If it's a literal, then we generate the literal string. And then if it is an argument, then we generate the argument set. Those are the 4 cases.
So as we go through component nodes, then we look up the target ID. We get the label here. And that already is because the literal nodes, they had only a single port. But here we need to go through all ports, I think. And we only care about the targets. Because the only things that would come as a source are the literal strings.
Well, actually, so of the things that you should go through, what you should be going through here are the assigned things, right? Like, so you generated the variables at the top, right? So what I would do is, so we have like C0, whatever that was. We take that thing, we look at that node, we go through the ports of that node, and then we see the target. Yeah.
I think that we are pretty close on that. Let's assign target. And it isn't a constant anymore. It's going to be like something else.
Yeah, there's 2 types of assignments, right? So like depending, it's either going to be setting directly to the value, or it's going to set its argument to the other argument.
We do have some kind of assignment source that uses so we have port source ID. Yes, it's something like that.
Yes.
Let's see what this does. Key error.
Because the named nodes might not, that only contains components, right? And so what we're looking here is not components. We want to ignore those, right? So we're only looking the target.
In here, we could have, so the only things that are not in the named nodes are literals.
Yeah,
so
or start.
We want to ignore if port source is how come that it still picks up that?
It is picking up that.
Which is the error.
Oh, well, the if source.file is none or target file none, that is opposite. We want to do we don't want to deal with the components where they have files, right? Like those things are not what we're going to do in this phase. We're only looking at
I thought we are at aren't we there already? Like the thing where there are no files, we did that already?
No, because oh, you did the literal things first?
Yes, I did the literal things first. Now I'm looking for the component argument things.
Okay. So they need to be connected to a thing that does not have that triangle in the port name or the port label.
Yeah. And well, there we have a triangle. Right. What did we have for values that are connected as values?
They're the things that we want, right? So like anything that doesn't have a triangle in the name. So condition.
Let's see.
So define variable component has an output ref that is connected to loop component's condition.
I think the easier way of dealing with that, I mean, it would be nice if you just
in the name.
set a different type or so on it. But if it starts with
unfortunately, we can't do that.
then it is one of those. If it starts with parameter, then it's parameter.
Yeah, I think
so. We want to collect that is a port, I guess. Oh, we already collect the port name. Nice. If port name come on. So that suggests
there
that
can
there
be
can be
com-
not
components
connected.
without any ports.
Now, if it doesn't have any ports,
Yes.
it's like you're
Yeah,
failing
so
on
the
one
end.
of those.
Yeah, like if I think you're probably looking at the print, right? So print has essentially an outflow node, but it doesn't have any arguments out or something like that.
Let's see where exactly it happens.
I'm probably looking at a start or something like that.
Okay, so those are gone now. Now we are failing on this. And let me quickly check my phone because it's blowing up. Okay.
Yeah, no worries.
So,
It's just work.
yeah, it's just more work. So it cannot find the source.
Can you search for that key to see which node we're talking to?
Sure. It is a literal string, which makes sense that it doesn't find things there.
Yeah.
Okay, we're looking at all the component nodes, and those can have as their sources something that is not part of named nodes, which makes sense because we have handled that before. So we want this, let's skip source named nodes. So we're going to skip that.
C1 ref.
This
that
should
is the
not
wrong
happen.
port. We're getting the wrong port. I think check the assignment. You're probably getting the left-hand side is the wrong thing.
So define variable component, parameter out, any ref. And it is setting up.
Yeah, so ref needs to go to the loop conditions condition, right? So C3, so the left-hand side, needs to be the port.
Yeah. So it's getting something. Well, it's getting
like
both
0.
things wrong.
Yeah, we're getting the first port, but we don't want the first port. We're iterating over those ports, right? So,
but
the first port
in here
is
we
the
want
triangle.
But I mean, we are on a port. So on the current port, okay, so this is probably just badly copy and pasted from
Probably
here.
easiest. Yeah.
Okay, so what we want to have here is to select the correct port name.
Yes, the current port name.
It should be just port label, I guess.
Yeah. Now the variable and then the port label will be equal to.
So C3.
Yeah, so that looks right. And then the right-hand side, same thing.
But it's a different port. That's the problem here.
Targets. It's the targets.
It's targets port that points to this thing. It feels like we are missing some information, like what we've collected.
Can you check? I think. Can you put and just like set the debugger there, and then we can like look at the objects that we have at hand.
Sure. Why didn't I do that earlier? So the port that we're currently looking at is a parameter int a. We have defined, okay, so C6 out number and C0a. Makes kind of sense.
Okay, so we're looking at the counter component.
Can you? I'm going to switch to your thing.
So we're looking at this
directly.
This link here. So this is called A, and this is out number.
And wait a second. We are on the node comparison component. So let me zoom this. We are on the comparison component. And unfortunately, I can't make this any bigger, I think. Or can I? Probably not. So our current node is the comparison component.
Yeah. That's weird. Okay.
It's just that because of the ordering, we end up being in different points. So, and the current port of that node that we are looking is the parameter called A, or the one that's labeled A. And its target.
We don't want this one. Let me open up the source code. So if we look at the source code one more time.
I think the problem is the same in like if we fix it on that component, it's going to be fixed on all.
Yeah. So
we want.
Okay. So if we look at my source code again, you can see A is set to C3 out number. Right.
Okay, that's good.
Yeah.
Because so we have A, and C3 is the counter component.
Yeah, that has an out number port.
Okay, so we have A with the counter component here, and we need to figure out which one actually connects to this port.
I think we look at
so we are missing, I think we are literally missing information in our parse tree. Like, I think we should be adding something here.
Port has
its name is because source and target just gives us the node.
But we don't know which port it's connected to.
Right. source name. Would be nice.
Mhm.
Because then you can literally just use source name instead of the searching there.
Yeah.
And it is kind of there. Because if you look at any link, we get the source and the source port.
Yeah.
And for the source port, I search for that. It's in the source port ID. So we do have that. Okay, we came from the target. Or did we come from the source port? No, we came from somewhere. Because source and target can be different depending on like the direction of the link.
We only have undirected link, but yeah.
Okay, if we only have undirected links. So
and C2 condition is
our port. Okay, so look at all the ports in there. And do you have nodes and links?
So if I'm not mistaken, we only care about the inputs, right? So we can filter out the outputs. So for example, if we go back to the compiled code and kind of put it side by side with the diagram, right? We have the define variable component and the loop component. Those are the first things here. So you can see that we set these, right? But there's no C1 ref, right? Then we're done with the inputs. So we go to the next component, loop component. It has a condition, and that is this. So we set that one here, and then we're done with the inputs.
Right.
So now we continue. Yeah. So if we filter on in,
we don't want any of the ports where we are the source.
I think.
So
yes.
You haven't added anything there. So if link like that. And now it's probably even. I hate that part, but the traversal syntax, or like the iteration thing. Oh,
yeah.
It's
when
in this case it's just that.
Yeah.
So we don't want to traverse any parts where we are the source of it.
And I just noticed Frieza was telling us we only process the end nodes, and I have no idea when he was saying. Yeah.
Oh, that was no. He just said that.
He remembered.
Just a minute ago.
Okay.
Oh, let's see what it will say. I think we said it. I can go one direction since so long it always made the code can weird. Yeah. And is that you want the target not to be source name? Oh, yeah, I did add the source name. List index out of range. Okay, let's go back here. So we want to traverse the ports only to add those ports where the link source kind of doesn't make sense. Because this even like if we use target here, it also doesn't make sense, because if we use source here, then we say we don't want to traverse the ports that are a circular, well, that are circular in shape. And if we say yes, and if we don't want to traverse those where the target is.
Yeah, I don't think we need to do anything this complicated, because the name, right, is either in or out, right?
So we get only the ports that go out, or only the ones that go in?
Only the ones that go in. Well, we do need them, but when we're doing the variable stuff, we only care about the ones that go in. All right, so we need the outs for defining the things, and then when we set up the nexts, we need those. But when we're defining the assignments, we only care about the ones that are in.
Are you sure about the names? Because the things that are, let's see if that is a literal to work well with.
So as Frieza is saying, the algorithm is we go node by node via triangles, right? And then for each node, look at the imports to see if they're connected. And if they are, then we put them in a list to be generated, right? And
I mean, we kind of do that on the initial parsing. Like we start from the start node and then follow everything. But the next part then is kind of murky.
Let me see if I can find an example node. So remember how there was like the ports in order and the ports out order? We could, so you're right. Essentially, in hyphen something is the triangle, right? And then out hyphen something is the triangle. And then we had parameter something something, right? Yeah. But whether or not that parameter is an input and output, we don't know unless we look at the ports in order, because the ID of that one is in the ports in order, and then the output ports are in the ports out order. So if we have the ports in order and the ports out order in our graph, then we can check if that node is in the ports in order. And if so, then it's an import. And you can look at my screen for
accidentally pulled the headphones out. I'm sorry.
Oh. Okay.
So I've missed the part where you just after, well, but I think I've got the idea. We need to be able to distinguish on the port whether it is an in port or an out port.
Yes. And for that, you need to look for the ID in the ports in order or in the ports out order, depending on what you're looking for. So this equal to this. So therefore, parameter any MSG is an in port or an in argument or in parameter.
Called imports, ports in order. Python doesn't have in line.
You can put if. Yeah, you just do it that. If, so you put the answer. So in, if, yeah, else, out.
Always forget how that is supposed to work. So when we go through this, essentially the flow parts and skip the literal nodes. We would probably do this. Do this only for the parts that are coming in.
Yeah.
Okay, so now that we have that, we need to go to part source. Well, we still don't know what the name of the port is that connects to it.
Yes, we don't know that. We know we can know that through the link. So the link the links.
We rename that. So
I kind of noticed that there's actually an in parameter that's true if it's in and false if it's out.
Do we? Oh.
Yeah, it's like, oh, yeah, that's yeah, that would do it.
Okay, so if port in. So for the source label,
much easier.
We do have this. as the target label because it's the port on this node. So that is easy. So we need to follow the link. And that link also gives us information what type of link it is.
Yeah.
That's actually quite useful. Okay, now it's getting a bit... Should we put the port type on it so that we don't have to do quite as much?
I think so.
So, what was this again? Yeah. So the type is the thing. Which is either triangle or custom. And well, we don't have any additional labels. Color and everything else doesn't matter. Okay, so we have that port type. We have the...
And then we need the target port. Or
yeah, so we have the target, which is that, and the target label is just the label. So the source label, we would follow, I guess, the source.
Yeah, the source port.
Which gives a, which we have. So this gives us the source node.
Yeah, we don't want the source node, we want the source port. Yeah.
So that is this
that
port.
has the label that we want.
But it is on that node. So first we get the node. Then we go to ports. And
where ID equals...
Okay,
yeah.
Let me do this a bit differently. Out equals that port node. Ports following thing that import port equals that out ports. Yes, we are getting quite a lot of complexity here now.
Yeah.
Yes. Equals that. Okay, a little little bit better and easier to follow. So we follow that back to the source node. And that in here, I guess. Okay, so first label, then is the source node. We want the ports, and there
ID. Yeah.
that is equal to link source port. Going to pull that out and get this label.
Yep.
I think. And that allows us to do more things. Like I think we should be able to replace that with just node. That's 0. Source label. On that. And probably we need to switch the names around.
Yeah. The ports 0 source label is not necessarily. Yeah, I guess, yeah. Because the literals only have one thing.
Source.
Yeah. Makes sense.
Right. But it should be target label, really.
Yeah, it's like the source from the link
target
perspective.
label. Yeah.
Yeah.
Okay. Anyway, let's see what we get. Port object is not subscriptable. Because that.
Yeah.
E. On that same level.
Yep. I'll allow it. Okay. So that is not right.
Yes.
So C2
but it also comes from
is
here.
equal to 1. Yes.
That doesn't make any sense, but yeah. I wonder whether that was just a fluke that works with 0 here. Because it's not necessarily the first port.
Yeah, that's what I was saying. Like it's not necessarily the first part, but regardless,
Wait,
we don't need to
the
do
literal
the literal
strings
nodes
only
separately.
have.
Yeah, the literal
Okay.
strings only have, or all the literals only have one thing, but we don't need to do it separately, right? Like I think instead of doing it separately, because we don't know which port is happening, we just go for each component, for each in port, right? Then we check, is it literal or is it not? And based off of that, we assign the way we're assigning now, or we assign the literal's label to the value.
Yeah, I think I get what you mean. Okay, also we can skip those with time. Okay, so that key error here, it comes from source ID, which makes sense because that gets a literal string in here. So we can. We're also only looking at those the direction in.
Yep.
So if the source ID is not in named nodes, that means we have a row, and else we have something else. So now the assignment first the assignment target is the value, and assignment source is what? Source. Oh, actually port.
Target label. Yeah, try that real quick to see the port. We're getting the
Not quite.
name value. Not quite, but better. So we're kind of getting back to ourselves. So like C1 name.value is name, and that's because we're looking at itself.
Closer.
Now that's
A lot
that's
closer.
good.
That is
The wrong one.
we're going to change that as we want that we have there the L body 0. This is their sign. LE equals it's value.value. Because why wouldn't it be? Okay. very close.
Yeah.
Now we only need to know whether it's a literal string or a literal something else. If part source name is literal string, else I'm going to that appears to do the trick.
Sweet. Cool. We're halfway done.
We're halfway done, and we have 3 more minutes until we have worked on it for 4 hours.
Yeah.
But we also made one significant change. That is that we've marked the triangle parts.
Yeah. And so now we look, essentially we kind of like connect everyone's triangle ports together. If so, the funky thing is that if it's called next, we just set it, and if it is not called next, we use subgraph executor. Essentially.
Okay.
And it can be none. In that case, we don't necessarily need to actually set none. Do we? It is Python after all.
Don't know. Depends on whether we set it by default or not. And probably we don't, because we've always set it in here. Okay.
Yeah.
So then, I guess we only care about the component nodes again. And we care about the ports, but only those that are out.
Yeah, only the out ones.
Yes, we can do that. Like that. Okay. Right. So we again first want to figure out what the target is.
Yep.
I guess the label is
should usually be next.
Yes, should be next. And it is next.
But next isn't written. It's not like written as next, I don't think, in the graph.
Yes. I think it is written
as
something entirely different.
Yeah,
I mean,
there's apparently Yeah.
Look at that. Finish node ID.
So in here,
so we can see
we're kind of looking for outflow, I guess.
and we have. Okay, there we can go with the names because it's always in something or out something.
Yes. And so if it's out underscore
like in 0 or out 0, then we use that.
next.
Yeah, we use next.
And then if it's outflow hyphen, we
then
use
what follows outflow.
Yeah. Then that's where the subgraph executor comes in.
Okay. Let's do that then. So if part name is out 0, then our assignment target is next. This assignment source is going to be just link nodes part source ID, I guess.
Yes.
And then we are going to append parse I expect that to fail in some way. Right. Because we may be looking at the initial start node. Pretty sure that is what we're looking at.
Yeah. Well, actually, we
looked at many components before we got there, and it is the branch component that we fail at.
The branch component, and it fails because
Can we take a look at the diagram?
Yeah, you can look
on
at
your
diagram.
Screen.
Was it?
Yeah.
Okay,
finding the right entitled one.
There we go. Okay, so there's definitely some bugs when you open it as source. Hold on, let's see if this fixed it. Oh, it was working for a second. Let me bring it back up. Find the where's my ID? I need, give me the URL. Okay, then we go to Chrome. new URL. Okay, now it's back to working. Ooh,
Kinda.
I really messed that one up. It was working. I swear it was.
Okay.
Oh god.
I
Let's
guess
try that
I'll
again.
move back to my screen and try to see what node it is looking for.
There we go. Oh, why does it disappear?
Oh, it
Did
is
I
the
break something in
finish
the source
node.
code?
I have no idea
Ah.
what you did.
Yeah, I opened it up as source here. And I might have changed something.
Yeah, I mean, that happens. But we found the thing that it is trying to connect to anyway. That is a finish node.
I see. So the finish node should be none. We should say that it's none in that case.
Yeah, it is kind of, I think something is backwards here.
Nope, I think that's right.
The assignment target.
Oh, it's looking named nodes.
Yeah, it's looking for the name of...
Yeah. The finish, yeah. So
but I mean, it's trying to assign the next of that.
Oh, that is backwards then.
I mean, yeah, we changed the direction, so a certain target should be different, I guess.
Okay.
And now let's get another one. Okay.
What is it?
I also removed the name. Obvious, but it's again branch component out is where it is failing. And it's looking for... Okay, I mean, oh yes, that makes sense. Because it is looking
for none.
It's none. Okay, we've got some things. C1 next is C3. Let's bring up this one. And
okay, so C1. Okay, so what's C1? In our case, it is
define
variable component. So define variable component should be connected to loop component.
That should be
C3.
C3 loop component. Yes.
Yeah. Okay. That looks good.
And the last one.
Then the none. C8. Okay, so the number of these things is a little sus.
Yeah, the numbers are, you mean the count of them, like in total, or?
Yeah. 1, 2, 3, 4, 5. And none. 1, 2, 3, 4, 5. Okay, yeah. So we got the numbers correct for the nexts, and then we need 3 more.
The subgraph executors.
Yeah.
Okay. So that is front name starts with flow. Then we need the target is a bit different. Because it is the port name without the outflow part. The source should be the same, right?
Target. Yeah, and then the source is the same, but we wrap it in the subgraph executor.
Yeah, right. Yeah, right. So let's have it that way. So that is that.
Yeah.
Yes. Forgot the column there. But we don't need the -1.
Hey, that looks pretty good.
Yeah, actually does.
Now there's some other nuns that we're not setting. So is that okay? I think it might be okay if we don't set those nuns.
I mean, they should be none by default.
Yeah, exactly. Okay, and now we just print out the trailer, which is if name equals main.
So let's
Then it'll be.
I guess I can just
we
copy and
forgot
paste
the. Yeah, so that actually still goes inside of main, and starts at C0 instead of C1. And then outside of main, we want an if name equals main, thing.
Ah, right. Okay, so we are still on main.
Yeah.
And
we append that code pretty much as is to the body, I think. Oh, we didn't define the trailer part.
I forgot the.
And then that you can copy paste as well. Maybe we can call it finished executing instead of finish executing. Okay.
So. Okay, let's see. None type is not terrible. Oh, yeah, because it's not
needs to return.
is complaining about that. Okay. Yes, that needs to be double slash.
Yeah.
Yeah.
Cool. So now run it.
Never. The biggest question is, will I be even able to run it? I mean, it doesn't need anything.
You have the components,
right? I've got the components. I've got that, so I can create a new Python file.
Yep. Call it my untitled, or output.py.
Yeah. Just going to copy that. It doesn't know where the subgraph executor comes from. This one does.
Because we have the XA components base that we were missing.
And where is it? Oh. Fixed imports. And I guess I'm not going to, okay, I'll check that it's there. But for now, I'm not going to. You know what? You can just write it down. With open outputs. Okay.
Cool. XA components base.
Yeah, no, it's a simple typo.
Oh.
Yes, it's an uppercase G in subgraph. Yeah. It didn't run this file.
There we go.
Now we run output. None type is not callable.
The next component do.
It starts with a branch component. Oh, I get it.
Oh,
because
yeah.
C0 isn't necessarily the first component.
That is true. The defined variable component is the first component. So luckily we know we have start, right? So we can set C0 to the output of start.
Okay.
We have the start node,
Yes.
right?
Start node, yeah. And now I need to run the compiler. And the start node.
We don't want the start node. The thing that the start node points to.
So that should have just a single port.
Yeah.
That has a target. That has an ID.
That
This
is...
time around is C0.
Okay.
And C0 is defined variable.
This is a defined variable. Yeah, so that works.
Yeah. Hey!
We're done. Yeah.
We're done.
Yes.
2 hours 20. 4 hours 20.
4:20. That means, you know what that means. If we're done in 4 hours and 20 minutes, gotta get some stuff.
Interesting.
That deserves a Negroni.
I think it's also exit code 1. It printed stuff, but apparently it was printing outputs after that. Set variable component object has no attribute next. So we do need to set the...
we do need those.
Empty next. Okay. Close, but no cigar yet.
Yeah.
Okay, what was that in particular? We need to set none on all the nodes that do not have a port that follows up.
Right.
Okay, so let's assume that
essentially it should be like if the out it's not necessarily if it has nothing in the out ports.
Yeah.
Because it could be a branch component with only one branch defined. So yeah, essentially we need to go through all the triangles, and if there is a link, it's none, and if it's not a link, or if there's no link, it's none, and if there is a link, we do the thing that we're doing. Yeah.
I think if because every node in the component nodes is going to have a next, right? So if we use...
everything has next.
That. And that doesn't matter. That should produce it. Okay, we have a few nuns this time around.
More nuns, yeah.
The start is at C2. And let's see.
Name none is not defined. What?
It's I've mistyped. It was num. Okay. Run it again. Exit code 0. Now it's finished.
Yay.
That's still 4:20 for me.
We're still technically, still 4 hours and 20-ish minutes.
Right. Cool. Great. So I'm going to push this as a work in progress.
Yeah.
I think that makes sense. Yes. It. And before I do that, I'm going to get rid of the printer. To add this or that, just this single file. And I mean, we've got a compiler in less than 250 lines. It doesn't do the debugging, but I think that's pretty good.
Yeah. I totally agree.
And let's push that. Okay, cool.
Sweet.
I think we're done with this. So
yes,
everyone who is
Go to
watching
bed.
this, who has stayed with us for that long, go to bed.
Yeah.
Yeah. Thank you everyone for tuning in. And I guess next week we will continue this, or maybe we'll do something different because we have finished this in between streams. But yeah, I guess same bad times, same bad channel next week.
Yep. Yeah, I think we'll maybe play around with some components, like spend most of the time instead of inside of circuits, but like using circuits to do something maybe with OpenAI. That'd be kind of cool.
Yeah. Well,
showcasing all the
that's
stuff.
probably
you
a
can do.
better thing to do than finishing that, because this is kind of just grunt work now.
Yeah. Okay, so yeah, we'll see you guys next week, same time. And looking forward to it.
Yeah. See you then.
Okay. See you guys later.
Bye-bye.